Here we go. One last rodeo. Let's do this. Okay, so what are the impacts, the ramifications? What the heck is plate tectonic doing to Earth? So a number of different things, kind of in general, even some things beyond geology. So first, let's talk about mountain building. So this is known, mountain building event is known as an orogenic event. So an orogeny is an episode of intense rock deformation or mountain building. It results from compressive forces, convergent boundaries related to plate movement. During subduction in that convergent process, sedimentary and volcanic rocks can be folded and faulted along the plate margin, along the boundary. Metamorphism can occur as well. More on that when we talk about rocks. Most orogenies occur along either oceanic to continental plate convergent boundaries or continental to continental plate convergent boundaries. Additionally, coming on back, ophiolites are evidence of ancient convergent plate boundaries as well. Ophiolites, those areas where oceanic crust and upper mantle material, which is very rare to see on the Earth's surface, get pushed up, abducted onto overlying plates and pushed up onto land. Additionally, there's something called the Wilson cycle that helps to describe the relationship between mountain building and the opening and closing of ocean basins, plate tectonics. More on that in a second. So here we go. So again, orogenies are mostly associated with oceanic to continental crust convergent boundaries, creating mountain ranges and or volcanic arcs. Also, orogenies are associated with continental to continental crust convergent boundaries, making large mountain ranges like that of the Himalayan mountains where Mount Everest is. Here is the Wilson cycle. So starting off, so the Wilson cycle takes 200 to 500 million years. So let's start off with a stable craton. Craton is a stable, unaltered piece of land, of crust, I should say. So, for instance, maybe, Africa, somewhere in the middle of Africa. All of a sudden, you get rifting that occurs. Rifting continues to happen. That might create some sort of shallow sea. The divergent boundary continues to occur, and now we have mid-oceanic ridge, and that's covered by ocean water. Continuing on, that divergent boundary, the oceanic crust and upper mantle, the lithosphere, is now converging with continental crust, creating volcanic arcs, and from there, subduction might continue to occur, thus closing the ocean. Now you get continental collisions happening. Ophiolites now are kind of slapped up onto land as oceanic crust mixed with upper mantle material gets abducted up and pushed up, and now we're back to kind of full continental crust and back to kind of the stable area, and then that happens again. That's the Wilson cycle. So anyway, plate tectonics causes mountains. There you go. Plate tectonics is also responsible for creating different what are known as terranes. Terranes are areas that differ from neighboring regions in fossil content, stratigraphy, structural trends, and differences in paleomagnetism, direction and strength of the magnetic field locked into those ancient rocks. These terranes probably formed elsewhere, and due to plate tectonics, sometimes they're carried great distances as part of other plates until they collided with other terranes or continents. And sometimes you can actually have a number of different terranes in what is seemingly a stable area, but when you look at the geology, there's a number of different terranes that have been kind of pushed up onto the continent, and it's just a bunch of stuff that kind of got pushed up. This is very common up in the North American Pacific Coast region, Washington up into Vancouver into Canada. So here's an example of that. We can see all these different terranes, different fossils, different rock types, you name it, different paleomagnetism. it's all one state. It's right. It's all part of the North American plate, but it's actually different terrains. And the way these all got here is maybe at a convergent boundary, this arc of stuff was pushed up, and then as that boundary continues, another arc of stuff was pushed up, and then another arc of stuff was pushed up. And if we were to slice this in half and kind of tilt it up and look at it from the side like layers of a cake, we see all these different terrains that have been accreted, added on to North America. So we can get different terrains even on a particular plate. We could have a bunch of stuff that's added. It's now all part of one plate, but they're different terrains, different fossils, different rocks, different paleomagnetism, showing these all formed different areas, but now they all got pushed up and squished together. So that's more geology. But what about life? I'm talking about the biosphere. So plate tectonics has a huge impact on the present distribution of plants and animals, which is largely controlled by climate and geographic barriers, right? Where the continents are now helps to determine the climate, and only certain plants can grow in certain climates. Physical barriers, mountain ranges, and other things create biotic provinces, keeping certain things in certain areas. Each of these different biotic provinces is characterized by different plants and animals. Plate movements also largely control, again, barriers. When continents break up, new provinces form. When continents come together, fewer provinces result. As continents move north or south, the climate changes. So where the plates are and how plate tectonics, is driven and how the plates move around greatly determines what's there, right? If the North American plate all of a sudden shifts north over the next few 100 million years, well, it's going to get real cold, and the stuff that lives here might not exist on this plate anymore, in North America anymore. Some example of physical barriers caused by plate movements include volcanoes, island arcs, mid-oceanic ridges, mountain ranges some animals or even plant species can't get over, subduction zone where things move away. So one kind of interesting example of a physical barrier created by plate movement is the Isthmus of Panama. That's this kind of location right here. Very thin, right? Very thin. But, before North America and South America were connected by the Isthmus of Panama, and or when oceans were higher, you can get organisms going either way. But as geologic forces, tectonic forces happened, as sea levels dropped, this barrier was created between the Pacific Ocean and the Caribbean Sea, which is part of the Atlantic Ocean. So we can look at, let me move me a little bit, Pacific species versus Caribbean species of the same type of sea life, and they're actually just a little bit different. There's some differences there. All right, evolution over time has caused that. All right, so these barriers can have an impact on life. What about natural resources? How does plate tectonic play a role in natural resources, what we mine? Remember, stuff only comes from two places. Either we grow it or we pull it out of the ground. We mine it out of the ground. That's it. That's where all stuff comes from. All right. For example, like my sunglasses, right? They're plastic. Like, wait, we don't pull plastic out of the ground. You're right, but plastic is actually made. It's a byproduct of petroleum, oil. Go figure. That's why plastic is nasty stuff. So, which oil we obviously mine out of the ground. So, if it's not grown, it's mine, right? So I have a notebook here, right? So trees are needed to make this, probably some other stuff. So if it's either grown or mined out of the ground. It's only two places stuff comes from. So plate tectonics plays a huge role in natural resources. Plate movements influence the formation and distribution of where natural resources are, such as petroleum or oil or mineral deposits. In a lot of places of the world, countries aren't poor just because they're not educated. A lot of places of the world, countries are poor because they don't have any natural resources to exploit. Or if they do, other foreign organizations have gone in and taken all that stuff. All right. Here in North America, we're blessed with a number of natural resources that have helped sustain our country. Whereas if you go, some random small island in the Pacific Ocean, it might be, a lot of poor people there. And it's not their fault. It's just they don't have resources there to exploit, to sell, to trade internationally, to make money. So, all of this is determined and dictated geologically speaking. Metal resources is related to igneous and hydrothermal activity. That's volcanic activity. And that can include things like copper, gold, lead, silver, tin, and zinc. Here in Arizona, we are the copper state, and we actually owe a lot of our copper deposits to hot magma activity at some point below this area of the North American plate, depositing minerals in the ground for us to mine out. And that's just the sheer dumb luck that at one point this part of the North American plate had some magmatic activity below it, that some hot molten rock just so happened to creep into this area, depositing gold, copper, a little bit of silver, a little bit of gold, those sorts of things. Just blind dumb luck. Magma generated generally by subduction can also precipitate and concentrate metallic ores. So some examples include other copper deposits in the Western Americas in general. So you notice there's a lot of copper deposits where? Right along boundaries. All right, so these boundaries must have something to do with it. Specifically, it looks like convergent boundaries, it looks like. There was some ancient convergent boundaries here. Now it's a transform boundary, but there was old convergent boundaries here. This is Bingham Mine in Utah. It is if not one of the biggest open pit copper mines in the world. It's kind of hard to see, but these little dots right here are these giant 30-foot high trucks that take material out of this mine every day, every minute, every hour. Operates 24/7. But there's also some large mines here in Arizona. The Morenci mine is one of them. Hydrothermal activity, hydro, water, thermal heat, magma heating up water to dissolve out and then later deposit minerals into cracks in rocks. That can also happen at divergent boundaries. Remember, the plate's thin, mantle material comes up, can heat up some material, heat up water to help dissolve things and deposit minerals. Examples of areas where that occurs would be like the island of Cyprus in the Mediterranean Sea, where you get copper concentrating from hydrothermal vents near some small divergent boundaries. And again, the Red Sea, which I mentioned in a previous section, kind of the same thing. A divergent boundary kind of runs right along underneath the Red Sea, pulling apart Saudi Arabia from Africa. And in doing so, again, copper, gold, iron, lead, zinc, silver deposits are currently forming in the Red Sea, in the bottom of the Red Sea, which is a divergent boundary. Again, rifting between the Arabian Plate and the African Plate. It's created this narrow sea. Over time, that will continue. The ocean will kind of creep in there. But as of now, again, you get this rising mantle material, heating up water, dissolving material, depositing natural resources. Again, all a byproduct of plate tectonics. There's almost every question in geology. You can be like, well, why is this? Plate tectonics. Why is there volcanoes over there? Plate tectonics. Why is there copper in Arizona? Plate tectonics. Why is the climate the way it is? Plate tectonics. Why is this species of animal over there? Plate tectonics. Answers a lot. That's why it's a unifying theme. Well, that's all I got. But before I go, let me give you one last part of the super secret code. Let me throw two more numbers at you. Let's go 9-5. You got me? 9-5. One more time, 9-5. So that should be a total, I believe, of 6 numbers that make up the code for this unit. All right? If you have any questions about anything, let me know. If not, until next time, we'll see you.